All right, so again, notes starting on page 41 here. Does anybody see, again, it says mentally, does anybody see a little trick that can help us with any of those? Brody?
16 goes into 17 once, which equals 1, and then 1 down, and it's 6, so it'd be 16, so it'd be 11.
So you're thinking 11. So you kind of divided it in your head.
Yeah.
Did anybody do it differently to get 11? Okay, when I saw that, I think, all right, 16 times 10. What's 16 times 10? Because that's an easy one, right? 160. How much more is 176 than 160? 16. All right? So it's 10 plus another 16, so I know it's 11. Okay, again, looking for little tricks like that to make it easier for you. How about 16 times what is 8? Anybody know that one? Yep. 1/2. Half of 16 is 8. 16 times what is 1? A little trickier. 16 times the reciprocal. 1 over 16 is 1. 1 over 16 is correct. So knowing that, 16 times 1 over 16, its reciprocal is 1. 1 over 5 times what is 1? So you're trying to find a reciprocal. Remember what reciprocal means? Flipped over fraction of 1/5. 5. 5 over 1. Knowing that, that should make the last one easier as well. 2/5 times what gives me 1? So the reciprocal of 2/5. 5 over 2. So again, little tricks to figure those out. Any questions on any of those? All right, question 2. Your teacher will give you a set of cards. You don't have those, but I'm going to put them on here. And we're just going to list the scale factor of these cards. If I can find them. All right, so I'm going to kind of just make a chart. I'll just make it up here versus on the board so everybody can see it. And we're just going to figure out the scale factor. All right, how much bigger is it? So we got to look at the length. We got to look at the width. And some of these are fractions, but let's just see if you can get the scale factor of that one. Molly, do you know that one? 2. 2. How many people agree with 2? All right, so this side is 2, this is 4. That's double. You could look at the other side and say that's the same thing. So scale factor of 2, I'm going to put card number 1 underneath there. Because it's going to ask us some more detail here coming up. Card number 2. They are all scale factors, so if you can tell one side, you should be able to get them all. 3 goes from 1 to 3. Notice anytime it goes from small to big, it's going to be a number bigger than 1. So make sure you watch the order here as well. But that one is 3. Card 2. Scale factor of 3. Card 2. Jonas. Half. How do you get half? What were you looking at?
I counted the top and it was 6 over, and then
1, 2, 3, 4, 5, 6.
and then on the other one was 3 over.
1, 2, 3. Could have counted down. 1, 2. This one's 1, so it's half as big. Very good. Scale factor of a half. Card 3. And again, it's going from big to small, so it should be a fraction. Does that need to be zoomed in a little bit for some of you? Okay, it goes from 3 to 1. That's definitely 1/3. Scale factor of 1/3, card number 4. We haven't really talked about circles here much. You can look at the radius or the diameter to compare those. It's going from small to big, so it's going to be more than 1. Let's look at the diameter. Diameter is 2. Here the diameter is 6, so that is times 3. Card 5, scale factor of 3. We already have that one written down, so I'm just going to add it to my tally there. Card 6. Big to small, it's going to be a fraction. So let's look at the top. 2, 4, 6, 8, 9. 9 across the top. I know they're all scale factors, so I don't even have to check the bottom. Top is 3. How do I go from 9 to 3?
It's a third.
A third. Divide by 3 or times a third. We already have that one written down, so I'm adding the tally for number 6. Card number 7. There's 13 cards, by the way, I believe. Okay. Goes from 4 to 2. Half. Card number 7. Card number 8. What do you think? Guess we'll just ignore the drilling this morning. At least I hope that's drilling. Bathrooms are below us, so somebody could be having a rough morning. Yeah. Yeah, it's the same shape. Easy one. We haven't had that one yet. Scale factor of 1, number 8. Card number 9. Let's look at the height. What's the height of the first one? 3. What's the height of the second one? So, 2. Card number 9. Card number 10. Kind of a crazy shape. Again, take the straight side if you can. So this side is 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Scale factor? 3. That's the third one of those. Okay, card number 11. Top is 2, the side is 1.
2.
Nope. Nope. 1/2, it got smaller, right? A to B, smaller. 11. Easy one? 1. Same is not a scale factor. Whoops. Yep. 1/3, 18 to 6. All right. So I got them all listed there. Top of the next page. Examine cards 10 and 13 more closely. What do you notice about the shape, size of figures? What do you notice about the scale factors? So 10 and 13. That was these guys. They're the exact same. Okay, one's going from small to big, one's going from big to small. And notice the scale factors. 3 and 1/3. What did we talk about in the first example today about those numbers? They're reciprocals. So if you know that from small to big is 3, the other way is the reciprocal. 1/3. That is always the case. If you go from small to big and it's 2, what would be the other way? 1/2. If you go from small to big and it's 5, what would be the other way? 1/5, reciprocal. Okay, so to answer that question, what do you notice about the shapes and sizes? What should I answer? They are the same shape. Maybe mention that it's a different order. What do you notice about the scale factors?
They're reciprocals.
Reciprocals of each other. Question 3. Take a look at 8 and 12. Do you remember what 8 and 12 were?
They were both the same.
Yeah, they were both the same. So, what do you notice about the figures?
That they do not change.
Same. Didn't change. I'll take that. What do you notice about the scale factors?
They are the same.
Yeah, they're the same. They're actually 1 over 1. I suppose you could still say reciprocal because 1 over 1 is flipped. Scale factors are both 1. Same. Are you ready? How many times bigger are the side lengths of triangle B when compared to triangle A? Alright, so triangle B is a scale copy of A with a scale factor of half. So here's A. Is B going to be bigger or smaller with a scale factor of a half? Smaller. B times a half. How many times bigger are the side lengths of B
Trick question.
compared to A?
Trick question. They're
Should
not
be half as big.
half as-
What if they switched it and said how many times bigger is A than B?
1/2. 2 times.
Twice, reciprocal. Remember, we just said if you go the other way, it's flipped. Question 2, imagine that you would scale B by a factor of half to get C.
Fourth is big.
How many times bigger will the side lengths of C be compared to A?
1/4 is big.
How'd you get that?
You take 1/2 times 2, which is 1/4.
Ooh, no. 1/2 times 2 is 1. 1/2 times 1/2 is how you got the 1/4. This fourth is big. So what if I asked you this? Boston? How many times bigger? Only Boston now. How many times bigger is A compared to C? 4 times as big. The reciprocal. Very good. C, triangle B has been scaled once, triangle C has been scaled twice. Imagine if you would scale it n times and go all the way to n, so you keep scaling it. Half as big, half as big, half as big, half as big, half as big. How many times bigger will side lengths be? Well, we got to take 1/2 times 1/2 n times, however many times it is to get to the letter n. I'm just going to put n because I don't want to count them. And we're not going to sing the ABCs. So 1/2 to the nth power, so however many letters it takes to get to n, is how many times you'd have to multiply it. It'd be pretty small by the end. Question 3. I want you to write skip by that one, because I want to make sure we have time for number 4. So on 42, you can just write skip by this whole one. And I want to make sure we get through number 4. Directions state, what is the scale factor of the original to its copy? Explain or show your reasoning. All right, so let's go to the next page. I want to give you 30 seconds to see if you can figure out the scale factor of that one. Again, we just did 13 of those together. Reed, what do you think?
1/5.
Confident?
Yeah.
Why is it not 5?
Because the original is 5 tall, and the copy is only 1 tall.
Okay, so it goes from 5 to 1. It gets smaller, so right away that should say, oh, fraction. Right? Smaller than 1. 5 times what is 1? Reciprocal. 1/5 is correct. Scale factor is 1/5. Now, if it would go from the copy to the original, what would the scale factor be? 5, reciprocal. Small to big, whole number. Bigger than 1. I guess it could be a fraction. I shouldn't say whole number. But a number bigger than 1. Next one. Scale factor from the original to its copy is 2. Draw the scaled copies. Bigger or smaller?
Bigger.
All right, now this one's a little tricky because of all the diagonals, right? So we just got to decide where to start. So we'll see this point here. I'm going to start it right there. I'm going to go straight down and say it's 3 down there. So on my shape, it should be 6 down. 6. Okay, and I'm going to put this dot in. I see it's to the right 1 and down 1, so I'm going to double that and go. It's 1 and 1. So I'm going to go 2 and 2. I'm doubling. Remember, this is 1 and 1, so I need to make mine 2 and 2. So there's the first part of my trapezoid. Now I could count the diagonals over here again, but now that I have this point, I'm just going to count how far left that is. Rylan, how far is this distance? 3, so on my new shape it's got to be 6. Okay, connect the dots. Should look exactly like the original, just bigger. All right, number 3 here I think is the trickiest one. The scale factor from the original to its copy, that's this way, is 3/2. But you'll notice this time it gives me the copy. So what would the scale factor be going back? 2/3, flip it, absolutely. So that's actually the number I care about because I'm going the opposite way. This way is 3/2, 1.5 times bigger. Flip it over, going the other way. What's 3/2 flipped over? 2/3. What's this length up here? 3. What do I need to take 3 times to get over here then? 2/3. What's 3 times 2/3? 2. So all these lengths that are 3 are now going to be 2. So I can draw this whole first part of the 9 because they're all 3 and I'm going to make them 2. What do you notice this length is? So what do I got to make it? What do you notice this length is? 3. I got to make it 2. Does that make sense? It had to be smaller because I took it times 1.5 and it got bigger. A lot of people will get confused on that and draw this original bigger, so make sure you follow directions. Maverick. Scale factor. 1, let's go. Same. Easy one. Don't get that one wrong. Question number 5. Notice now I don't have a grid. Part of the reason we're going to have a ruler starting Monday. You'll be able to measure it. Again, you can use any sheet of paper, anything you got, to measure that. Okay, so I'm just going to make a note here of my paper. How many times do I have to write that? 3. 1, 2, 3. Again, connect them the best you can. There's my line on the 4. Next part, I'm going to figure out how far this distance is. Just this little piece here, and I'm going to triple it so I know where my line goes. Yes?
Is it gonna mess it up? Because I already did that. Like, I just added it up.
No, that's fine. You don't have to go this order. So I'm going to measure that, and I'm going to measure back 3 of those. 1, 2, 3, so I know my line's going right there. So I got to measure how far down it is. Triple it. One, 2, 3. Connect them. What's my last step? What part don't I have yet? The top. I'm gonna do the top, and then I don't even have to touch the slant part of it. So there's my top. Again, it's triple. 1, 2, 3. That's how tall it goes. And your last step, simply connect the dots. So I never did measure that slant. I didn't need to. I measured the straights and connected dots. Again, your 4 should look exactly like the original. Don't make that face, Rylan, or it doesn't look like the original. Do the best you can. Be easier once you're able to measure. But we can get by. Again, good summary on the bottom, page 45. And here's the whole point. On page 46, the scale factor is 1.5 times bigger, 3/2 going this way. Remember, the other way is just the reciprocal. So knowing that is the biggest thing on today's lesson. Is going to make it a lot easier for you going forward. Okay? Your assignment. Starting on page 47. Let's read the directions here, and some of you might have started on this if you got done map testing. Decide if the scale factor is greater than 1, equal to 1, or less than 1. So I'm just answering that for every one of these. So does a shape get bigger? It's more than 1. Scale factor more than 1. Does it get smaller? Less than 1. Is it the same? Is it equal? Okay. Brody, pick a letter. G. Let's look at G. Going from P to S. What do you think the scale factor is? Bigger than 1, 1, or less than 1? Why? Yeah, so I would write down equal to 1 on that one. That's all you do for those. You got to answer every one of them. Want to do one more, or we got it?
We got it.
All right. Number 2, S and L are scaled copies of one another. I'm glad they wrote that down for us there. Everything's on the next page to answer. Number 3 and 4, please, and 5. Please circle the word explain, explain, explain. Okay? Don't mean to stress you out, but you have 5 questions today. Okay? That's the most we've done. All right, you got about 10 minutes to work. Let me know if you have any questions. That'll be due